Kamiak Butte is a unique land feature located on the Palouse in Washington state. In this presentation, we will look at the ecology of the butte. When talking about the ecology of Kamiak Butte, it is important to first describe how it was formed. Roughly 100 million years ago, much of the Pacific Northwest was still under the ocean. Therefore, Kamiak Butte was oceanfront property. This is why the butte has a quartzite base due to all of the sand that is compacted on it over millions of years. When we flash forward to around 14 to 17 million years ago, a hotspot drifting east through Washington began to cause fissures in the Earth's crust that poured out lots of magma. These flows of lava eventually spread through much of the western U.S. throughout Oregon, Idaho, and Washington. The lava eventually cooled and became basalt bedrock. These basalt flows were so massive that they were up to 2 miles thick. The sheer mass of these flows caused the lithosphere to compress and much of the landscape to be buried underneath the rock. However, the top of Kamiak Butte managed to keep its top above the basalt flows, and this is what we see of Kamiak Butte today. "2.6 million years ago, an ice age began that caused glaciers to creep down from Canada into much of the northern U.S., including Montana. These glaciers were heavy enough to compress the lithosphere even more. Around 12,000 years ago, these glaciers began to melt when the temperatures started to rise. For a while, the melted water from the glaciers was dammed up behind a 3,000-foot wall of ice near Missoula, Montana. This caused a glacial lake to form that at one point was 2,000 feet deep. Eventually, the water broke through the ice and flooded over much of eastern Washington, exposing the basalt flows and creating the channeled scablands. Eventually, the floodwaters were backed up at Wallula Gap, where they flowed into the ocean. The lakes formed from the floods eventually dried up. This left lots of topsoil and debris, including organic material, to pile up in large quantities. The soil was then picked up by strong winds and blown to the east of areas like Wallula Gap, where Glacial Lake Lewis formed, and blown onto the Palouse, where it created a low soil that in some places today is 20 feet deep. Today, Kamiak Butte sits above the rolling hills of the Palouse, relatively unchanged compared to the land around it. Unlike the dense layer of basalt that surrounds it, Kamiak still has a quartzite substrate from when it was oceanfront property. Climate is the long-term patterns of temperature and precipitation of a given location. Kamiak Butte has a marine-modified continental climate. This climate is much drier than the marine climate that lies west of the Cascades. The main factors that influence climate are air masses, continentality, and topography. Air masses are important to climate because they move weather systems that can determine temperature and carry moisture to areas. Air masses can also be responsible for moving topsoils to different regions, like I described previously. The marine polar air mass is what affects Kamiak Butte. However, Arctic air masses from the north can mix with this air mass and form cold winter conditions. Continentality can be described as the distance between marine and continental climates. For instance, the marine climate to the west of the Cascades has more precipitation, which causes more plants to grow there. Areas like the Palouse have less moisture and less plant cover, which increases Kamiak's albedo, or the amount of solar radiation that reflects off of its surface. Topography can affect the climate by disrupting air masses or changing the way precipitation is dispersed. This can be illustrated by the rain shadow effect. We can use the Cascades as an example. As a cloud comes off the ocean and reaches the base of a mountain, it is forced upwards where it gets colder and the atmospheric pressure on it increases, causing it to rain. When the cloud comes down the other side of the mountain, it warms and the pressure on it decreases, which makes it much less likely to rain on the backside of the mountain and the land behind it. Aspect is a factor of topography dealing with which compass direction a slope faces and can have an impact on solar radiation on that slope. Speaking further on aspect, the south-facing aspect of Kamiak Butte is exposed to the sun for much of the day and therefore has high rates of evaporation and less plant life. The north aspect is sheltered from direct solar radiation most of the day and therefore has more plant available moisture due to the less evaporation and more plant life. When it comes to temperature at the butte, it gets tricky. In order for plants to photosynthesize, they need to have temperatures around them above 40 degrees for 48 hours before. So as you see in the climate chart for Kamiak Butte, May through September is the only months where conditions for plant photosynthesis on Kamiak Butte are ideal. This means that most plants have to be very hardy and not depend on large amounts of water to thrive at the butte. The biome of Kamiak Butte is the western interior shrublands and woodlands biome. This biome consists of coniferous trees, grass plains, and shrubs such as sagebrush. The biome is known for having a dry climate with cold, harsh winters and summers that are hot and usually very dry. The plants of Kamiak's biome consist of native grasses such as blue bunch wheatgrass, which is shown here. Grasses do well in this biome due to their fibrous roots that lock in soil moisture. Coniferous trees such as Douglas firs grow well in this area due to their long taproots that reach deep down into the soil to get water. Plant density in this biome depends on how much plant available moisture there is, so the more hardy a plant is, the more likely it is to succeed on the butte. The Palouse region where Kamiak Butte is located is known for its fertile loess soils. This has led to agriculture completely taking over much of the land in the area surrounding the butte and drowning out native vegetation. As well as this, humans have increased the likelihood of wildfires that have the potential to greatly affect the butte. The mesoclimate is what makes Kamiak Butte unique from other areas. The butte is uniquely affected by wind, temperature, and precipitation due to its features. Kamiak Butte sits at an elevation of 3,641 feet, meaning that it is unsheltered from the sheer force of winds and has to deal with colder temperatures than the lower areas that surround it. As well as this, Kamiak Butte is still affected by the rain shadow created by the Cascade Mountain Range and therefore receives little rainfall compared to areas that lie just to the east of it. The south-facing aspect of Kamiak Butte supports few trees at only around 35 trees per acre. The north-facing aspect of the butte is much more dense with trees, at roughly 130 trees per acre. As well as having more trees, the north aspect also can grow mosses and ferns. There are many biotic factors that have a tremendous impact on how Kamiak Butte looks and functions. The main factor that I've talked about already is plant available water. Another very important biotic factor that affects Kamiak Butte is deer. Deer have little predators to worry about up on the butte and therefore eat large amounts of native plants. This overgrazing causes small plants like the Saskatoon serviceberry to hardly produce fruit that many smaller herbivores like rabbits use for food. Humans are another biotic factor affecting the butte. Humans have installed wooden steps and barriers to create hiking trails on the butte that cause unnatural patterns of erosion when it rains hard. When it comes to abiotic factors at the butte, wind and snow are two large factors. Wind speeds can reach high gusts on the Palouse, which may cause aging or dead trees to topple over and change the ecosystem in some instances. In the winters, snowfall can reach a couple of feet deep up on the butte and cause obstacles for many of the animals that inhabit it. Wildfires are also a large abiotic factor on the butte because they can drastically affect both the animals and plants on the butte in a negative way. There has recently been evidence discovered that leads to the belief that cougars may be living on Kamiak Butte. Recently, a potential cougar den was found on the butte that looks like it has the potential to be used by a cougar. As well as this, cougar tracks have been found in the snow on the butte. With Moscow Mountain being the nearest known cougar habitat, it may be possible that this cougar leaving tracks on the butte may have traveled over from Moscow Mountain. If a cougar or several cougars were living on Kamiak Butte, they would definitely have a healthy population of deer to feed on. Also, the thick tree stand on the north-facing aspect would provide great cover for which cougars rely on to ambush their prey. However, certain people may make Kamiak Butte an unfavorable place for cougars to live. For instance, cougars are known to be very solitary and not like human interaction. So with hikers frequenting the butte, cougars may not find the butte very suitable, and landowners may feel threatened by the presence of a cougar. So would Kamiak Butte's ecosystem benefit from cougars living there or not? I believe that in summary, yes, it would. This is mainly due to the cougar's ability to keep deer populations at a healthy level. By doing this, many small trees and shrubs, such as the Saskatoon serviceberry, would grow to be much larger by the reduced grazing of the deer and provide more habitat for smaller animals and in turn benefit other predators of those animals such as hawks and owls. I believe that cougars living on Kamiak Butte would cause the ecosystem to return to a more natural and balanced state.